Welcome to this visual explainer. We'll be decoding the fundamental law governing exactly why things move, or, more accurately, why they stubbornly refuse to move at all.
Let me just ask you a quick question to kick things off. Why is the universe so, lazy? Seriously, think about it for a second. It's a totally relatable, everyday observation that things in our physical world fundamentally resist change. If something is just sitting there, it wants to keep sitting there. It's almost as if the objects all around us have this inherent laziness built right into their very DNA.
The formal academic definition. It states that a body remains at rest or in uniform straight-line motion unless acted upon by an external, unbalanced force. And this right here is the strict scientific way of describing that exact laziness we were just talking about. Basically, nature absolutely loves the status quo.
Now, let's take that dense academic jargon and break it down into a few incredibly simple, undeniable facts. First off, objects simply will not change their state on their own, ever. If they're at rest, they stay at rest. If they're in motion, they're going to keep moving in a straight line with a constant speed. A change in motion only happens when an external, unbalanced force steps in and acts on that body. Because, trust me, they won't do it themselves.
Moving on to our next section, rest inertia versus motion inertia.
Check out the visual comparison here. Over on the left side, we've got rest inertia. Imagine a simple coffee cup sitting perfectly still on a counter. It's peaceful, completely undisturbed, and 100% committed to remaining exactly where it is. It stays still unless pushed. But now, shift your attention over to the right. This is motion inertia, and it's super dynamic. A ball that is already rolling keeps rolling, aggressively maintaining its momentum in a perfectly straight line. It has a powerful tendency to just remain in motion.
Let's ground this with a really concrete example. Just picture a heavy physics textbook sitting quietly on a table. This is the perfect illustration of rest inertia, because that book is essentially just patiently waiting. It has absolutely no ability to initiate a change in its own state. It'll just sit there for eternity until someone or something comes along and provides that external force to push it.
Now for some everyday physics. Real-world inertia, the sudden bus start.
Right, so have you ever wondered why you violently jerk backward when a bus you're standing on suddenly accelerates? Well, let's walk through the physical mechanics step by step. First, the bus starts suddenly. Second, because your feet are firmly on the floor, they immediately move forward with the bus. But third, and this brilliantly illustrates our whole concept here, your upper body possesses rest inertia. It tends to stay exactly where it was. So fourth, the bus and your feet move forward, while your upper body's laziness gets it left behind in its original position. And the result? You jerk backward.
Next up is the mass connection.
A feather and a bowling ball clearly don't have the same level of stubbornness, right? And that brings us to a really crucial mathematical rule. Inertia is directly proportional to mass. It's an elegantly simple formula. More mass literally equals more inertia, and less mass equals less inertia. Mass is the single variable that dictates how much an object resists change. It's exactly why you can easily flick a pebble out of your way, but there's no way you're flicking a boulder. The boulder's massive weight makes its inertia, its stubbornness, astronomically higher.
Inertia is nature's way of saying no change without a reason. It really brilliantly humanizes the physics, doesn't it? It just cements the concept that the universe isn't chaotic. It follows strict rules. To change the motion of a body, an external, unbalanced reason, a force, is absolutely non-negotiably required.
So we've seen that mass dictates inertia and that nature absolutely demands an external force to change the status quo. But this brings us to a fascinating final thought to leave you with today. If the law of inertia is an absolute rule and objects in motion are supposed to stay in motion in a straight line, well, why doesn't a rolling ball on Earth just roll forever? What invisible external forces are secretly acting on that ball to finally make it stop? Think about friction. Think about air resistance. The universe is literally full of hidden forces, and understanding inertia is really just the first step to seeing them all.